titled Towards Medical Foundation Model, a unified dataset for pre-training medical imaging models.
So surprise, surprise, there is 3 of us. UMIE Datasets is actually a team of effort. It is entirely community-driven, so we wanted to highlight it in our presentation. So I'm joined today with Kacper Knite and Bartłomiej Kuchnowski. And we are going to share with you the exciting milestones in our project. So actually, UMIE Dataset stands for Universal Medical Image Encoding. And this project is meant to answer one of the most important growing pains in AI for healthcare, like we heard in the very first presentation in this session today. So the lack of large-scale, annotated, open-source medical datasets.
Okay, so we shall start. Thanks. So, as all of you probably know, there's a paradigm shift within the community to move away from one model per specific task and go into models that perform well on multi-model data sets and for multiple tasks. And this is the same for medical community, however, not without problems. So this is an example, and I mean no shade for the paper because it's great, but just last year, Zhu et al. Released a foundation model, which is for OCT, that is only one type of image of retina in the eye that predicts only 10 different diseases. So it is still a narrow task, and this is kind of a trend that is going in medical imaging community. There has been some shift recently. Just last week, actually, Microsoft released a MedImage Insight foundation model. However, as you can see, a reference to Hitchhiker's Guide to the Galaxy. There have been some problems. They bound it to Azure. You have to log in. So what a wonderful Alexander Buchowski from our team did, he fixed and cleaned up the model and released it on HuggingFace, making the open source truly open source. So basically, I think it boils down to data, as it always does. However, medical data is specific, and the main problems here are that research papers do not make their data public. There is not enough open source data sets, mainly due to privacy reasons, regulatory reasons. There is lack of standards for storing data, and there is lack of standards for the data labeling. And I will show quickly what I mean. So here's an example from 2019, where Barbara here with her team trained a model for kidney tumor malignancy prediction. That means whether a tumor is cancerous or not. And while they were doing it on open source dataset Kids23, they did a quick literature research, and as you can see, 30 research papers that did kind of the same thing. From 30 of them, only 20 relied on the Kids23 dataset, which is the only one open source dataset for this type of diseases to date. And 24 of them relied on private datasets. There's not enough open source dataset, but it would be disingenuous of me if I didn't mention a few ones. So there is a cancer imaging archive from NIH. There is Kaggle, which all of you of course know. There is Grand Challenge, which is kind of a Kaggle for biomedical community, done by a team in Radboud UMC, which is a large clinical hospital in Netherlands. However, you know, the data tend to not to be persistent, and the data sets are sometimes gone, as you can see in this example here. So it's kind of a problem within the community. What I've also mentioned is lack of standards for storing data, and here's an example for previously mentioned Kids23 dataset, where you can see there is a kind of nice nifty format for imaging and segmentation, and you have label in JSON. However, if you go to another examples, which is Stanford COCA, you can already see that the mask is in dreadful XML, which is hard to read. And another example for chest X-ray 14, which has multi-label classification in CSV. And I think you can see that the multi-label means that if you run a quick function for showing what labels are within the dataset, you can see that multi-label means that there is only one label where there is a bar between labels, so it's kind of hard to discern. There's also lack of standards for data labeling, and this is a partly on medical doctors, which I am one of. That is, there are some, for example, there are some mental shortcuts. Here is CC papillary, which basically, it's not a label of sorts, but a doctor probably wanted to note that the tumor that is described here has both CC and papillary characteristics. And there are also regionalisms, so things that are said in one country which have no translation in the other, so like serce oparte na przeponie. And this is where UMIE shows up, and this is kind of the team's answer to all these pains. And I think that Kacper will now describe briefly what we mean by that.
So here we come with a solution. Universal Medical Image Encoding, in short, UMIE. In UMIE dataset, we have collected over 20 open source datasets, which give us over 1 million images, which include CT, MRI, and X-rays of various organs. For each of these datasets, we have created a pipeline to convert different image and mask formats to one common for the entire UMIE. Our pipelines are set of steps, universal steps, so you can easily use them for processing your all pipelines. For example, let's take Stanford COCA dataset, which have images as in format DICOM format and masked in XML. DICOM format in DICOM format you can store images in PNG, JPEG, or even as raw bytes. And and mask in XML have form of dictionary of arrays of dictionary, so it's kind of messy. And instead of processing it ourselves, you can just add 2 steps to pipeline and it will get job done. About some technical information, our pipelines and steps are based on sklearn pipelines. And if you want to learn more, feel free to check our repo. So in summary, using UMIE dataset is like playing with Barbie dolls mix and match series, where we provide you all the tools and you use only those that fits you the best. So.
Since we are working with datasets coming from all over the world, from many different institutions, a huge task for our team was to make sure that the same label, the same concept is not defined twice under 2 different names. And for this task, we decided to use RadLex ontology, which is an ontology of most common radiology findings and observations released by Radiological Society of Northern America. Each finding in this ontology is assigned a unique identifier called RadLex ID. We work with a radiologist to map the existing labels and masks in the source datasets to RadLex labels. And however, RadLex ontology is neither perfect nor complete. So for some labels, we could find a very precise, very accurate RadLex ID. But for the other, we had to use a more vague, more general label. And an example of such case you can see on this slide. So here we have pneumonia dataset, which had originally two labels, bacterial pneumonia and viral pneumonia. And in RadLex, we could find a RadLex ID for pneumonia viral, but there was no such precise label for bacterial pneumonia. So we solved it in a way that we converted this problem to multi-label classification, where pneumonia viral was assigned two labels, pneumonia viral and pneumonia. And pneumonia bacterial received only one label, pneumonia. Another challenge that we sort of fixed in our repo was the licensing issue. So although we have a growing number of open source radiological datasets, some of these datasets do not allow for redistribution. So you can use it to train your model, but you cannot re-release the dataset in the same or the slightly changed format. So for this purpose, we sort of employed a dual approach. So for all the datasets that we combined in UMIE, we release a clear manual for how to download the datasets from the source repository. And then we also add the preprocessing pipelines that we created ourselves to change these datasets to the common UMIE format and to our ontology. And for the selected datasets, we also created a repository on HuggingFace for the datasets that do allow redistribution. And actually, we are releasing this HuggingFace version of our project today. So we can be the very first users of our repo. And lastly, why do we even need a large-scale dataset of medical imaging? As we also could have seen in the first presentation today, right now the default method for creating AI models for radiology is still pre-training from ImageNet. And we are hoping that with the distribution of our dataset, we could see the growing number of foundation models for radiology. Since the last time we presented, we reached another milestone. So we can see, right now we have access to not only our GitHub repo, but also to HuggingFace datasets. And we are also going to release our model probably next year, and it is also going to be open source. We'd also like to give a shout out to our team. UMIE Datasets is driven by the community. Each one of us contributes to this project in the free time. So we'd also like to give a shout out to the team members who cannot be with us today. And you can access both our GitHub repo with the preprocessing pipelines and our dataset on HuggingFace. So now moving on to the next slide. So lastly, a bit about us. The Lion AI is an interdisciplinary research group devoted to creating open source solutions for healthcare, like the one you've seen today. We also have another huge project, which is about creating the very first Polish medical large language model, which is also going to be released open source. We also share a ton of free educational stuff, like the series of books on prompt engineering and medical computer vision. We also have a new series coming on murder mysteries, helping you get to know LLMs. And lastly, we would also like to invite you to the poster session tomorrow, where our Polish medical large language models team is going to tell you more about this project, which is coming very soon, and soon you're going to be able to access it open source. So that's all from us, and we would be very happy to answer your questions.